All right, everyone. My name is Danica. I lead open source developer advocacy at Snowflake, which means I get the privilege of talking about only the best open source technologies out there. Today we're going to cover a few of them, not Streamlit, I'm so sorry, that's a different talk. But we're still going to have a lot of fun here, okay? And we're going to build an on-air sign. So I've done a couple IoT-related talks over the course of my career, only because I really like to build something. I don't like to build toy projects. I want to build something that actually solves a problem in my life. And so this was a real problem in my life, in that I work from home sometimes. And I record content, or I'm on calls. And my boyfriend walks into my office, even though the door is shut, and asks me, oh, do you want lunch? And it's very annoying, and I have to tell him to leave. And so I figure if I built some sort of indicator light, I could solve this problem and eliminate some headaches between us. All right, so we were going to build an on-air sign. So bottom line, I wanted a way to connect what's going on in my computer, right? My camera usage, am I currently recording something, and also my Zoom meeting activity, am I on a call? And I wanted to connect that with some sort of indicator light, an on-air sign that we're going to build, and we're going to use a Raspberry Pi to do this. So ideally, I'm going to capture this information from my computer as close to real time as possible so that it can update that light in real time, right? And there's a lot of different technologies that you can use to make this happen, to build this sort of real-time piece in between. But I'm going to choose Apache Kafka. I've done a lot of Kafka in my time, and I think it's a very useful technology for you all to be aware of. Because again, this isn't just a toy project. I want to give you skills that you can actually use across real production use cases here. So we're going to add Apache Kafka in the middle here, and I'm going to feed these camera and Zoom events into Kafka and use that to power the on-air sign directly. Now, again, I said there's a lot of different technologies we can use in this middle piece instead of Kafka, but I think that the benefit of using Kafka here over some other messaging systems is really the persistence of the data. So while I don't really need to keep my data in Kafka beyond this initial streaming use case, right? It powers the light, that event is useless after that, kind of. But that doesn't mean that that data isn't useful for some other use case, okay? So we're going to do a little bit of stream processing. We're going to take advantage of the fact that we've persisted this data, do some stream processing with Apache Flink, and then we're going to write this data into Iceberg tables for long-term storage so that we can do way more interesting analytics down the line. Okay, and I want to call out here before we get into anything beyond this, that this is a very real tech stack, okay, for very real production use cases. And so I'm hoping that beyond you obviously following along and building this for yourselves, that this is going to be useful for you as you go back to your actual jobs, okay? So let's build something. That's why you're here. All things considered, I've built a couple IoT projects in my time. This was a very simple system to put together, or compared to the other ones I've done. So I'm going to pretend, again, that you all are going to follow along and build this exact same thing for yourselves in your own home. So I'm going to do my best to outline exactly which supplies you need to do this. First up, most important thing, Raspberry Pi. You can technically do this on Arduino. I'm the wrong person to ask about that. Next, for the actual on-air sign, I decided to go as rudimentary as possible on this because I wanted the ability to customize it further. Maybe build some 3D printed components to really make this feel my own. So I got an RGB LED matrix. It's 64 by 64 pixels. A bit rudimentary, but there's a lot more you can do with this. And then finally, because we have this whole grid of 64 by 64 pixels, that's a lot of individual components that need power, they need to be coordinated, and so you also need a matrix hat, an additional component to sit between the Raspberry Pi and this actual matrix, this sign. It provides additional power and then just makes it a lot easier to interface with the sign, okay? So this list, it's not exhaustive. As with every IoT project, you're going to hit an issue, and you're going to be like, oh, I forgot to buy that thing. But thankfully for this one, as I said, it was a pretty simple project to pull together in that the suppliers that I used had literally every piece that you needed was linked directly to that component. Okay, so you couldn't miss it. Or if I did miss it, I actually did miss a couple. Thankfully, I had that sitting in my garage already. But if anybody's curious, I can link to at least the US supplier on what these pieces are to put you in the right direction so you can get started on your own. Okay, so this was a simple IoT project to put together. I'm going to keep selling that because I do think it is. But it's simple if you ignore the next critical step, which means that you need to do some soldering. I think this is a great opportunity for all of you to get a soldering iron, if you don't have one already. So, it's pretty great. Soldering is required for one, you just need one dot of solder, which is really annoying, okay? It wasn't like you had to solder everything. But I did solder everything because I like to test myself. So I ended up doing that. I tried to avoid soldering, but you really do. You have to jump a circuit on the back, depending on the size of the LED matrix that you choose, because they have many different sizes for you to play around with, okay? So here's the proof that I did the thing, in case you didn't believe me. Ignore my messy workstation. I think only about 40% of the things up there were actually used for this project. The rest is just constant mess in my workspace. But this is immediately post-soldering. I plugged everything in just to make sure that the sign itself works. And what was really cool, this is why one of the reasons that I thought this was a very easy project to pull together, is that when I got into IoT projects, you're starting to cross over into, okay, you're debugging from a software perspective, and like, oh, did I just type that thing wrong, versus did I actually plug that thing in correctly? And sometimes it's very difficult to figure out which one is which. And so thankfully, when you actually, there's a driver associated with this matrix. And so when you actually install that on the Raspberry Pi, they have some built-in demos, which is fantastic because that's super easy. You know exactly what that demo is supposed to do. And if it does that thing, it means that you plugged in all the physical components properly. You didn't solder the wrong thing, which was great, okay? So the sign does the thing, or it actually works, right? So now I had to install the sign. So I know I said that this is going to be an on-air sign to really honestly just tell my boyfriend not to come into my office when I'm busy. So it needs to be outside of my office, right? Well, I just renovated my house, and I wasn't really ready to like mount something on my hallway or on my door. So right now, because it looks cool, this lives inside of my office, which I think defeats the purpose of this entire project. But hang in there. There's some other cool use cases that make this useful, I promise. And this is temporary. It's kind of just chilling on my shelf until I find a better place to put it. But it's going to be worthwhile even in this state, I promise. So the sign is plugged in. Now let's actually do something with it, right? Let's generate some events. And so we're going to be using Kafka here, as I mentioned. How many of you are familiar with Kafka? How many of you have used Kafka? Okay, handful of you. For the rest of you, what is Kafka? Great question. It's a distributed event streaming platform. In this case, we have events. So for this use case, we have camera data, meeting information. These events, these messages, are being produced to and stored in individual partitions of Kafka topics. They're data sets in Kafka. And these events, these messages, are stored by their timestamps inside of these partitions. Once the data is stored in those topics, any number of downstream consumers can come along and consume that data from the Kafka topic in order by those partitions, and it's going to consume that data in a way that doesn't affect other downstream consumers, okay? So you can have these completely decoupled pub-sub systems, but Kafka also lets you build systems that take advantage of the fact that there can be multiple partitions in a single Kafka topic, and then we can parallelize the processing of the data across those partitions. Okay, so Kafka is a really cool technology. You can look up some of the other talks I have about it. I love it. I think it's fantastic. If you're not using it, find an excuse to use it, like building this. I'm just saying. But yeah, so Kafka is a distributed system. You have to run a cluster somewhere. For at-home use cases, that doesn't sound very fun. But you can run it in Docker containers on either your laptop, or you can run it on a few Raspberry Pis if you're feeling really wild and you just want to do that. I have yet to do that. It's on my wish list. We'll get there at some point. But if you're hands-off, if you're like me, you can spin up a free service, a free account on either Confluent or MSK and just kind of try it out and just build it out and try it. All right. So once you have your Kafka cluster running, I know I'm doing some hand waving there, you have to have the Kafka cluster running. Now we can start thinking about actually capturing these events, generating this data into the Kafka topics. So I always advise, as a best practice, before you generate any data into a Kafka topic, really sit down and think about what that data should look like, okay? It's just going to save you some headaches later on. So for this particular use case, the first thing we have is our camera activity. Okay, so camera activity is pretty cool because not only do I want to know if my camera is on or off, it could also be useful from an analytics standpoint to understand which application is using that camera, right? Is it a recording software? Is it Zoom? Is it something else? I want to be able to accommodate that. All right, so I factored that in my schema that I created for my Kafka topic. This is an Avro schema. And then we also have our Zoom usage. I could have made this generic, like, meeting, is the meeting happening, is the meeting not happening? But for 99% of my work use cases, my work calls, they happen over Zoom. So I figured it was, I'm going to cover a large swath of my use cases if I just make the Zoom, but I can make this generic later on. All right, and so here I'm just capturing, okay, what is the timestamp of this event? Is it on, is it off? And I'm doing the same thing for the camera as well, in addition to capturing that application. All right, so for each of these schemas, I'm going to create a respective Kafka topic for it. For the time being, because this is a relatively scaled down use case, I created them with one partition each, and I'm going to set the retention time on the Kafka topic to be just 1 week. And this is, I have flexibility to change these things later on, you do as well. But for this use case, it kind of made sense to keep that data around for a week, and I have time to deal with it, move it off the Kafka topic later, okay? So with these Kafka topics created, I can then focus on actually producing the data to the Kafka topics. So when we look at capturing our camera events, I actually had a lot of fun trying to figure out how to capture camera activity on my laptop in real time. The other complicating thing about it was that, I have the built-in camera, right? We all have the FaceTime HD, whatever that camera is that's built into the MacBook. But I also have an external one that I use for certain recording pieces. Yeah, and I want to be able to accommodate. I can't just track the FaceTime HD camera. I want to accommodate the fact that I have other cameras that I'm going to be using with my MacBook at other times. Okay? So in the end, after scraping through the MacBook logs, because that's what I had to do, I was like looking through the log stream and like turning the camera on and off, like, okay, what event is actually useful here? But to that point, I could leverage the built-in macOS log stream. How many of you have used this before? None of you. I love teaching this to people because it's super useful. MacBooks have a built-in unified logging system. Really nice, well, when you actually need to use it. But with Logstream, it streams all of the events real time to you, to command line, and then it also has a built-in predicate filtering, okay? So you can play around with that and have certain things spit out for you. But basically, in the end, I found out that every time I change my camera, I turn my camera on, turn it off, the phrase AV capture session is contained in there somewhere, okay? So I could use that, I can assign that to the predicate, and I can filter for that, and this basically is a good enough proxy to tell me, okay, is my camera on or off for the purposes of a call? Yeah? And so I have that. Great, that's a really, really handy command line feature. So let's take it, let's execute it within Python using subprocess and have it be a long living thing. So every time one of these log lines appears, I can then capture that, I can extract the relevant information, map it to the schema that I created, and then produce it to Kafka. Bam, does it feel like a hack? It doesn't matter, because it works. All right. Now, for our Zoom events. So one thing I want to call out here with the camera events is that this is real time. This is as real time as it gets, right? I am monitoring the log stream on my MacBook, and every time there's a trigger, right, that the camera changed, I'm capturing this event and I'm producing it to Kafka. That is an event-driven system, okay? I want to call that out. We're not going to get so lucky on the Zoom stuff, okay? This is a little more involved. I could not find an easy way to capture Zoom events and have them pushed to me, okay, as much as I could with the camera events. So I had to be a little more proactive. This isn't going to be as event-driven. I have to actually fetch the Zoom status to see if I'm in a meeting or not. So this is going to feel a little bit more like a hack, but hacks, again, they work. So basically, I found out that I could check how many ports I have open in Zoom at any given time. And that's a good enough proxy to tell me if I'm in a meeting or not, okay? So basically, I could execute this like every second or so. That's real time enough for the purposes of turning on my sign, right? Every second. So similar to before, I can run this using subprocess in a Python script, doing this every second again. And if the result of the above command is 0, it means that Zoom is not currently in an active meeting. Which was nice is this also accommodates the fact that, I don't know about you, but in the morning when I log into my computer, I launch Zoom and it's just running in the background forever, okay? So it's not a question of whether or not Zoom is up and running, it's how many ports. So if there's 0 ports, Zoom could still be up and running, it's fine, it's just hanging out there. If it's anything more than 0, I think it's usually 4, it means I'm currently in a meeting, okay? So I can extract this, map it to my schema, and write that to my Kafka topic. A hack, great. All right, so this next bit is not glamorous, but unfortunately we have to make this real, and it's so boring. But so the scripts that I wrote, for monitoring my camera and Zoom activity, they need to be long-living. I don't want to have to log in every time and execute these scripts. So I had to figure out how to schedule a script on my MacBook. How many of you have had to do that before? Like 2 of you. Great. For the rest of you, it's really not that bad. You take whatever script you've written. In this case, it's camera monitor.py, and you create something called a plist file, a property list file. And so a couple things you'll note here. I have it's a very simple property file here. You define what this, you give it a label, you define where that Python script actually lives, and you tell it what to do. In this case, keep it alive. Okay, start it. So even if this script fails, and I do have logging in there, so definitely have some logging, so you're not just running this broken thing, it'll be brought back up at the end, even if it dies. All right? So you take this plist file, it needs to be saved in the launch agents directory on your MacBook, and then you can use the launch control command line tool to load that, and then also start it for the first time. Okay? But any subsequent time, it's just going to be launched when I log in. Okay? So with those 2 scripts up and running, here's just, here's what the events kind of look like when I consume them from Kafka. So everything that you see here is what we discussed on the schema itself. But you also see that I have a key that I set. In Kafka, it's pretty important to key your data. It's very useful, good practice. So here, I gave it the key workmac because, I don't know about you, I have many devices in my house. So maybe I just run this everywhere, and I can capture whatever I'm doing on all my machines. Could be fun for the purposes of analytics. Yep. Okay, so at this point, I have written the script to constantly monitor my computer for those camera and Zoom events, and we're writing that to Kafka. So now all that remains is to consume that data and use that information to power the on-air sign. Simple. So we're going to write yet another Python script. In here, we're going to use the Confluent Kafka Python library to set up 2 Kafka consumers to read the data from those respective events, those topics, the Zoom topic and the camera topic. So within each iteration of the while loop, I'm going to attempt to consume from each of these topics and extract that status if there's a new message in them. Okay? From each of these functions, I'm going to return a Boolean is on if that sign should be on from the perspective of both the camera event and also from the Zoom event, right? Because it might be the case that only I just have my camera on or I'm just running Zoom without a camera. Okay, so we want to accommodate for that. You'll also see here that I'm feeding in the past iterations result of the loop. Okay? Just because I'm trying to pull data from that Kafka topic does not mean there's going to be a message for me to actually read. So the result of me pulling might just be nothing. Okay? And in that case, I want to return whatever the last iteration was, because if the camera turned on, then okay, and I don't have a message now, that means the camera's probably still on because it hasn't turned off. Yeah? So this is just sort of completing that loop there. So I have 2 functions that are doing this. This is just the one from the camera perspective, and I have one doing it from the Zoom perspective as well. So from there, I can take those 2 Booleans, and we're going to decide if the light should be on or not. It's pretty simple Boolean logic. I'm not going to explain it. Missing from this code snippet is a little bit of boilerplate code from the LED matrix. Is this me making noise? OK. Thank you. All right, so we are combining the 2 statuses from there to decide whether the light should be on. Missing from this code snippet is a little bit of boilerplate code just setting up the LED matrix. It's a weird way to think about it. We're so spoiled for choice when you think about GUIs and stuff. And when you go back to actually rudimentary components, it's like, hey, pixel by pixel, you can control this. So it's a little bit of a learning curve here. But basically, I'm setting up the canvas, define some colors there as well, draw the text. There are built-in text options for this monitor, which is super cool. It has 3 fonts. They're all the same, but slightly different sized. It's great. But yeah, so I check the Booleans, and I can decide, OK, if either of them are on, great, we are going to display on air. Otherwise, we can do something else. Hello world makes sense, because what else would you put on there? OK? Yeah, it does the thing. Woohoo! Yeah, so within a second of me turning on my camera, it will display on air. This being behind me in my office is cool because it just looks fun on a Zoom call. Again, completely defeats the purpose of me actually using this as an indicator to the people in my house. Can you hear me? Great. Cool. So at this point, we have a working model, right? We're collecting the camera and meeting information. We're sending that to Kafka. We're driving the sign. We accomplished the very basic thing that we wanted to accomplish. But can we do more? The answer is always yes. So here's a reminder of the plan. So we've done this part yet already, right? We have our event-driven pipeline to drive this sign, but we can make it more interesting. And for those of you who have not dealt with Kafka before, Kafka is great for a lot of things, especially when you want to build an event-driven system like we've just done now. But the reality is, as I kind of mentioned before, that the time to live on these events is very, very low. Right? If I, for some reason, it doesn't power the sign in that 1 second, it's like, okay, great, catch me at the next meeting. It probably doesn't matter, okay? But just because that event has such a low TTL for the actual event-driven use case does not mean that that piece of data is not useful for something else later on. So we're going to, as I mentioned before, we're going to offboard that data using Flink. We'll do some stream processing, offboard it to Apache Iceberg, so that we can do way more with the data later on. Okay? So at this point, you might be asking yourself, why are we bothering with analytics at all for this real-time use case? You promised me an on-air sign. I don't care about the rest of it. That's a great question / complaint. But I'm going to answer that with another question. How many of you use Google Calendar? Okay, most of you. So I don't know about you, and you probably haven't seen this. I look at it a lot. But they have a very fun, very stressful feature called Time Insights. It's a love-hate relationship for me, but basically when you launch your Google Calendar, in the corner, it will tell you how much time you spend in meetings, and it sucks. I started my new job in November, so it just got worse from there. Anyway. So I haven't taken an updated screenshot. Maybe I should, or maybe I shouldn't. It'll just get worse. But it's really cool because it shows you how many hours you spend in meetings. It gives you a cool breakdown into the different types of meetings, and it has different metadata, right? Because it runs all of your entire calendar. But I could do something similar with the information that I have, right? I'm capturing the time that I'm spending on calls, like actually on the Zoom call, or actually with my camera on. So I can recreate this for myself. And since I have that additional element of camera data, I can answer questions pretty much like, oh, did I brush my hair today? On whether or not I was in a call and my camera was off, right? That's really what it comes down to usually. But I could also see how often I'm just recording things, and I'm not on a Zoom call. And so there's something fun that I can build here, right? So that is our motivation for offboarding this data into Iceberg, is so that we can do something interesting with it later on. Even though it doesn't matter that this is real-time data before, now we can do something with it later on. So we're going to use Apache Iceberg for this. You might be wondering what Iceberg is. How many of you know what Iceberg is? And the rest of you, you're about to go on a ride. It's going to be great. So Iceberg, it is an open table format. It's purpose-built for handling large-scale data sets in a data lake. So it's not a database in and of itself. It's a specification on how you organize data in a data lake context to better coordinate accessing and then updating that data later on. And it does so by adding an additional layer of metadata on top of the data files that you want to be storing in your data lake anyway. So Iceberg is the love child of a data lake and a data warehouse. It is a data lakehouse. We actually call it that, okay? You get the convenience and flexibility of data lakes with its cost effectiveness. You get the structure of data warehouses and ACID guarantees. We like those sometimes. Iceberg is great because you can write your data once, and then the whole selling point of Iceberg is interoperability. Okay? You write your data once in Iceberg table format, and then there's dozens and dozens of tools for very different use cases that can consume that data, and you can do different things with it. Okay? So to really drive this home, I do think that Iceberg is a really great add-on to an event-driven system like Kafka. I've seen this a lot in real life that folks are doing. You take your event-driven data that's very useful in real time for very specific use cases, and then you offboard it to Iceberg to store it long-term for more analytics. Okay? So it integrates really nicely with this real-time stack. So I'm not going to spend too much time on this, but I wanted to give you a glimpse of what Iceberg actually is. So it's a layer of metadata that helps to coordinate your data. So Iceberg itself specifies how to build out this metadata layer. It doesn't do it for you. You have to, it's left as an exercise to the reader. But if you adhere to this, it means that you're Iceberg specification compliant, and that means that you can maintain compatibility with other engines that know how to read and write this Iceberg specification as well. Not going to go into all those details, but yeah, just to give you an idea of what that looks like. One key component of Iceberg that you need to be aware of is that we have this idea of a catalog here. So this metadata and this data, this is just for one Iceberg table. And over time, the number of files here is just going to grow, okay? Which is kind of chaos. And if you have multiple engines trying to access these data files at a given time and updating them, that can be even more chaotic. So you need a catalog in there to help us maintain consistency when we have multiple engines trying to use this data and write to this data at a given time. So the catalog component is super important. Iceberg doesn't maintain a catalog specification or implementation for you. So there's a lot of different open source ones that do that. And in this case, we're going to use something called Apache Polaris. That's the logo there. Okay. But those are the high-level components of Iceberg. We have that metadata layer. We need a catalog. But Iceberg is just a format for storing your data, nothing more than that. I just want to specify that. But that doesn't mean it stops there. The great thing about Iceberg, as I said, is interoperability. There's a lot of tools that can work with this, and you have a lot of flexibility in what you can actually, how you can consume your data later on. So you're going to interact with your Iceberg tables using some sort of compute engine or query engine. The Iceberg project does maintain support for Apache Flink and Apache Spark. It's built in with the project, so you can get started writing your Iceberg tables using these two tools. But the ecosystem of Iceberg tools is growing. This is just a subset of some of them. And there's many, many more out there that cover very specific use cases, sometimes in the AI space.
Is Iceberg also distributed? Or?
Is Iceberg distributed? No. All right. So that's Iceberg. Sorry to bore you with that, but I love Iceberg, and I will tell you more about Iceberg if you ask me about Iceberg, okay? But bottom line, it's a great next step if you're working with Kafka data and you want to do some analytics on top of it. It's a great way to offboard your data before you decide what to do with it, yeah? So we need to figure out how to move our data from Kafka into Iceberg. There are a couple main ways that you can do this. Which you choose is going to depend on your particular use case, what you and your teams are familiar, because now I'm speaking to you as an engineer, going back to your job. What are you going to choose to move your data from Kafka to Iceberg? And there's a lot of factors that are going to come into play to help you decide what to do, depending on what features of Iceberg you actually need, what tools are already available in your stack, if you're approaching it from the Iceberg perspective or the Kafka perspective, do you want it to be real time, do you need to do more stream processing? The list goes on and on. I'm going to save you some time, and we're going to use Flink. Okay, how many of you have used Flink before? Great. Again, for the rest of you, I love this. This is great. You're going to learn so much. And I have stickers for each of these technologies, okay? So Flink is a distributed processing framework. It is flexible to do both batch and streaming use cases. It is very good at processing Kafka data. I think the Kafka source in Flink is probably the most popular source that Flink has. But Flink's great because it has a lot of different layers of APIs depending on your particular needs and use cases, including a SQL wrapper. Okay? So we're going to use this to read the data from Kafka and write that data to Iceberg tables. And in my opinion, I think it's a really good way to get started with Flink without sort of burdening yourself with Java. Okay. So reading from our camera activity topic is pretty simple. So at this point, getting started with Flink is super easy. You read the docs, great. I'm sorry. Read the docs. It's pretty simple to run it. You have to run a Flink cluster locally, but then you can play around with the SQL wrapper, and it's pretty simple. But once you have that SQL shell running, accessing the camera activity topic is pretty simple. We are going to create a table. Things in Flink are table-based. So we're going to create a table called camera activity. We're going to outline the fields that we have in our schema. And then there's a bunch of stuff from line 7 onward to finding how we actually, what we know about this data set. We're going to use the Kafka source connector. That's on line 8. We define which topic we're accessing, and then the rest of it is kind of boilerplate stuff that you'll need for any Kafka consumer. Okay? And I'll point you guys to the repo, don't worry. Right. One thing I wanted to call out here, hopefully you can see it, is on line 6. One cool thing about Apache Iceberg is that it has something called hidden partitioning, which one of the benefits of it is that you can use a transformation on an existing field as the partitioning field when you write it into an Iceberg table, which is really useful. It saves you space. Then the engine can track that. It understands if you're transforming it, and it'll apply that transformation if anybody else tries to filter on that field, even though they're not aware of how you've transformed that field. Okay? So it's really useful for your business users that have no idea. They're not reading the docs. They have no idea what you partitioned on, but they still want to get the benefit of how you partitioned the data. It's really nice. Bottom line, Flink doesn't do that. All right? It does not give you the ability to do that transformation on an existing field as you partition the data, which is annoying. To kind of get around that, I am creating a new partitioning timestamp field that I'm going to use to partition my data when I write it to Iceberg. And I'm just extracting the day of the timestamp, because I want to partition by day. I want to bucket everything by day in the end. So I wanted to call that out, because hidden partitioning is a really cool thing to be aware of. It's a shame that the Flink wrapper doesn't actually handle this right now. But in Spark, you get that, and in a lot of other engines, it's built in. So we're going to do the same thing, similar thing with the Zoom activity topic. We're switching out just the topic and the fields, but we're still going to extract that day for the partitioning timestamp. And so at this point, we've loaded our Kafka data. As soon as we establish those tables, we're loading our Kafka data into Flink SQL. Okay? But now, to prepare to offboard that data to Iceberg, we first have to prepare Flink to connect to S3, because that's the object storage I'm going to store my Iceberg tables in, and so on. So this starts by defining, or in this case, connecting to a catalog. Remember I said the catalog is really important in Iceberg. You need one. You can't get around it. I'm so sorry. They maintain our ACID guarantees and any sort of consistency. You need to have one. Okay? So outside of the Flink SQL client, I'm running Apache Polaris. Really great quick start on how to get started with that, how you can run it on AWS if you want to do that yourself, but you can also run it locally for yourself as well. So within Polaris, I have that running. I have defined a catalog. I've created roles and privileges. There's a lot of governance built in there. I've assigned these roles and privileges to myself as the user, the only person using this catalog. And then along with that, I've created some credentials for myself to authenticate as myself in the catalog. Yeah? So by running this statement, I am giving Flink access to that catalog. I am allowing myself to create tables within Polaris catalog, Iceberg tables, that then Polaris will store in S3 for me. Okay? So from there, we need to create the camera activity and Zoom activity tables within Polaris. We already have the Kafka-based tables in Flink. We're consuming that data from Kafka and populating those tables. But now we need to create those tables on the Iceberg side in S3. We do that by issuing the create tables command within the Polaris catalog in Flink. So we have polaris.onair.cameraActivity and also the Zoom activity one. So we're basically redefining the same tables that we saw before. But in this case, I'm specifying partition by. And I'm saying we're going to explicitly partition by that partitioning timestamp that I called out already. And then from there, the last thing we do is select star from the Kafka datasets and insert it into the Iceberg datasets. Okay? So by doing this, we can make this a long-living thing. This is just a one-off thing, but I can make it long-living so that every time another row is pulled into the Kafka table, we're going to move it into Iceberg for us. Okay? But this is something, I'm not going to get into too much of it and bore you, but you want to group as much data together as possible before writing it into Iceberg, just to save yourself, make it more efficient with our file sizes. But I'm not going to bore you with that. We can talk more about it. But anyway, here's some proof. It does the thing. So after running this, and the screenshot's old, I'm so sorry, but I wanted to show off that this is partitioned in S3. It'll create these directories, and within that are the Parquet files of the Iceberg data broken down by day. Okay? And so this isn't a very glamorous way to end. I'm running out of time. I'm already speaking very quickly. But there's more. I want to give you more. I want to tell you what more we can do with this. Because really, I want this to be a jumping off point for all of you as you explore these technologies for your own. Okay? But once the data is in S3, once it's in Iceberg format, we can use any of those Iceberg-compatible tools and engines to then just play around with this data in whatever way you want, to your heart's desire. It's great. But to leave you with something fun, I wanted to show you my very exciting backlog of things that I'm still trying to do with this, because when you have time, you build out the IoT project and you keep going, right? It's your personal project. So this is where I hope to take this, where I currently am and where I'm taking this next for the project. First thing, productionalize everything, because I hate that I have any sort of, I have to spin up anything. Trying to move everything to AWS. I have productionalized Polaris that's already running there. I don't have to think about it. And I'm also working on migrating my Kafka because work will pay for my MSK, so we're going to just throw it on there. But a stretch goal, like I said, is running everything on Raspberry Pis in my home, if someone will pay for it. Also, speaking of the Flink SQL pipeline, what I showed to you is just one instance of bringing up the, a Flink SQL shell and playing around with it. But I'm working on sort of scheduling this. So at the end of every week, I want to offboard all the Kafka data into Iceberg. So I already know that I want to do that on like Saturday morning, right? I don't have calls over the weekend. That's so silly. And so I'm working right now to sort of schedule that and have that come up every weekend to do that for me. From there, really I'm just playing around with the data as it's populated in Iceberg, and I can use whatever tool. I work at Snowflake, so it's very easy for me to connect this to Snowflake and play around with it. But there's a lot of lighter engines that you could use for your own use cases as well. So the big thing that I'm doing right now to make this analysis easier is I'm using Flink to better align these events as they both flow in. Because I want to know when I have my camera on and I'm on a Zoom call and vice versa. Like I want that granularity of the data, and then I can sort of measure the intervals, how long I'm actually spending on doing these things. The other thing I'm doing is building out a real-time chatbot. In one of my other projects, I have a chatbot that tells me when my plants need to be watered. So I'm using the same framework to create a chatbot so that in the event that my boyfriend is too lazy to come near my office to see if the light is on, because remember, the light's not outside my office, now he can text the chatbot and ask if I'm on a call. So see, the data's still useful. It's still useful, okay? So I'm in the middle of that, but it's just a fun way to still take advantage of the real-time data and play around with it and have him query that. And then I want to extend it to more use cases with IoT, because right now it's all driven from what's on my camera, on my computer. But sometimes I might be taking a phone call, right? Who does that? Some people take business calls. But if I'm on my phone, I also want to illuminate the light and say I'm busy. So I'm working on 3D printing a base for this and having buttons on my desk so I can say, oh, I'm on a call, and like turn it on, turn it off, and do that for other cases too. So the possibilities are endless. It's great. So just to leave you with a summary so you remember why you were here, why you came on this journey. So this was the original plan, right? We wanted to connect what was on my computer to this on-air sign and show you how to offboard this data for other use cases later on. I think this is a pretty cool use case. Hopefully you enjoyed coming along for this ride. But I do want to remind you, again, that even though this was a fun use case and you saw something interesting that hopefully you can play around with yourselves and you're encouraged to do it, this is a real set of technologies that you can use in very real use cases in production. Okay? A lot of companies are following the same format. They're pulling these technologies together in exactly the same way. And so I'm really hoping that this was sort of an upskilling opportunity for you. Play around with these. Even if you only run it for a week or so, I think it's really good to just know how these pieces, these components fit together, because it's just very useful for a lot of use cases. So I encourage you to play around with these both personally and professionally, and let me know if you end up doing it. So with that, thank you for coming on this journey with me today. Here's a link to my link tree if you want more resources on any of these technologies. I update them pretty regularly. Or give me a follow across socials. But thank you so much. I really appreciate it.
We barely have any time. One question. Just one.
Sorry, maybe you covered it in your slides, but I couldn't understand where so there's some Kafka code, like the consuming part of the Kafka code, is that happening on the Pi, or is that also happening on the, what's sending the signal from the consuming of the Kafka stream to the Pi?
Yeah, the Kafka consumer is running directly on the Raspberry Pi.
Yeah, and the last question is I couldn't fully understand the link because you said you're doing Kafka and then you're doing to Iceberg and then to Flink and then to Polaris. Is that the right order? Or?
So the ordering is that the data's in Kafka, and then we're going to use Flink to consume the data from Kafka as well. And then within Flink, we're connecting to Polaris, which then writes to Iceberg.
Okay.
Yeah.
Iceberg comes at the end.
Yeah. I will be around. We have a Snowflake booth, so if any of you all want to talk, and on your way out, I do have stickers from all the things we talked about. So if you want any of those logos, come over here. But yeah, I hope to talk to you all. Thanks.
Let's thank Danica.